Okay, let's take a look at this hypothesis testing problem involving an average and also a small sample. We have 5 measurements of the octane rating of a high-grade gasoline. Do we have enough information to conclude that this is indeed less than the advertised value of 91? Okay, so the null hypothesis is that no, it is equal to 91. The alternative hypothesis would be that the mean is less than 91. Okay, now this is a t-test, so our test statistic t will be equal to x bar minus mu over s over the square root of n. In our case, let's figure out what the average is. The average, so let me make these a little bit smaller so we have some space on the right. The average will be equal to the average of those 5 numbers, which works out to be 90.3, while the standard deviation, the sample standard deviation, is 1.29. And so let me write down what we're about to compute. Up here we have 90.3 minus 91 over 1.2903 divided by the square root of 5. And so the t value will be equal to 90.3 minus 91 over the standard deviation over the square root of 5. So negative 1.213. Okay, we now compute the p-value. To get the p-value, I have my t distribution with 4 degrees of freedom. Negative 1.213 is over here, negative 1.213. And because this is a left-tail test, I need simply the area to the left. And so the p-value will be equal to t dot dist of the t value, which we found to be negative 1.213. We have 4 degrees of freedom, and it's cumulative. So I get a p-value of about negative 1, or of about 0.15, 0.146. This can also be computed on a TI calculator using negative 10 to the 99th as the left endpoint and negative 1.213 as the right endpoint, and being sure to input 4 degrees of freedom. Alternatively, a second way of doing the problem, which I will do in red, will be by using critical values. In this case, I want to have 5% of the area lie to the left. So alpha will be 0.05, our standing assumption unless we say otherwise. And we figure out the critical value using Excel. The critical value would be t.inv 0.05 with 4 degrees of freedom for negative 2.13 about. If I want more decimal places, negative 2.1318. If you do not have access to Excel, or if your calculator does not do a similar exercise, then of course you can use the table that'll provided on the exam. In our case, the value of negative 1.2 falls over here someplace, not in the shaded region. And so our decision will be, I'll just type up here, we retain the null hypothesis, or we failed, let's write it out, we failed to reject the null hypothesis. There is not enough evidence to think the octane rating is different than 91. Okay, so that is the way to do this particular hypothesis testing problem.